Indices and Surds. Indices. Indices is actually plural of index, and index stands for power. Look at this number 4 power 3. Now 4 over here is base and 3 is power or exponent. There are certain rules in indices. First of all, when you multiply and bases are same, you simply add the power. In division, when bases are same, you will subtract the denominator power. Anything raised to the power 0 is 1. Square root of anything is power half, like a power half. And if suppose there is an index, this small 3 or whatever number is appearing here, then you will write reciprocal of 1 over that number. Otherwise, it remain 1 over 2 for simple square root. Power raised to the power get multiplied. 1 raised to the power any number is 1. It's a past year paper question. Bracket open 81 x power 16 power 3 over 4. So first of all, the power, this power comes separately on all the numbers elements inside the bracket 81 and x power 16. So I'm writing 3 over 4 on 81 and as well as on this x power 16. Power raised to the power get multiplied. Now it's better if you take prime factors of 81. 81 is 3 power 4, and if you simplify, this 4 and this 4 get cancelled out and you get 3 power 3. Likewise, 16 multiplied by 3 over 4 is 12. So this is the answer. Same way we have 1 over y raised to the power 2 raised to the power minus half. Now this power will come separately on numerator as well as on denominator. Power raised to the power get multiplied. So over here, this will be y power minus 1. 1 raised to the power any number is 1, and it's 1 over y raised to the power minus 1, and write it in positive exponent, so it will go up and become y. Again, there is a past year paper question. You have x raised to the power 2 over 3 divided by x raised to the power 8 over 3. So x power 8 over 3 is in the denominator, bases are same, both are x. So denominator will go up and get subtracted, minus 8 over 3. And if you simplify, you get x power minus 2. And if you write it in positive exponent, then 1 over x squared is your answer. Now 16 is equals to 64 power k, and you have to find the value of k. Again, you go for prime factors, get the prime factors of 16 and prime factors of 64. 16 is 2 power 4 and 64 is 2 power 6. And if you simplify, you get 2 power 4 equals to 2 power 6k. Since these two numbers are same, bases are same, and it is an equals to sign in between, so we can say 4 is equals to 6k, which give you k equals to 4 over 6 or 2 over 3. Now in this question, 3 is a prime number, but 9 is not a prime number. Take 9 as a prime factor. So 9 is 3 power 2, and this power will come separately on 1 as well as on this 9. 1 power anything is 1, and while 9 is 3 power 2, power raised to the power get multiplied, so you get 8 minus 6x. Now if you simplify, the denominator thing will go up and get changed, subtracted. Minus 8 plus 6x equals to 3. Simplify your left hand side, so it will be 9x minus 8. Now this is 1, 3 power 1. So I can say 9x minus 8 equals to 1. Simplification will give me x equals to 1. Now we have surds. This square root sign is a surd sign, and there are certain rules. If something is appearing two times under this square root sign, it will come out of the surd sign. Square root of a multiplied by square root of a is a, and there is a past year paper question. Square root of 175 minus square root of 28, and you have to simplify it. For simplification, you have to take prime factors of 175 as well as 28, and if something is appearing two times in this, it will come out of the surd sign, square root sign. So I've written square root of 175 as 5 under root 7, and square root of 28 is 2 under root 7. 5 under root 7 minus 2 under root 7 is just like 5x minus 2x. So I'm getting 3 under root 7. Rationalize the denominator means remove surd sign from the denominator. The simplest way is to multiply and divide the denominator surd thing under root 5, multiply and divide by under root 5. Why divide? Because you want to balance it. You cannot do anything on your own. If you're doing it, you have to balance it. So numerator get multiplied by the numerator, denominator by the denominator. 2 times under root 5 is 5, so this is the answer. Then again it is simplify. Square root of 300 minus square root of 48. Again you go for prime factors of 300, prime factors of 48, and anything which is appearing two times will come out of the surd sign. So you can see in 300, 2 and 5 are coming two times. They are out of this surd. And from 48, this 2 and this 2 come out like this. And 3 is left. And here 3 is left. So it's 10 under root 3 minus 4 under root 3. Again, it's just like 10x and 4x. So 10 under root 3 minus 4 under root 3 is 6 under root 3. Again, rationalize the denominator, but this time you have an expression under root 7 plus 2. So how, in this case, get rid of this surd sign from the denominator? You will change the sign in the middle. You have plus 2, so write minus 2 and multiply and divide by under root 7 minus 2. This is the step. Always change the middle sign. And then multiply numerator by numerator, denominator by denominator. In denominator, we have a plus b, a minus b applicable. If you're looking for shortcut, if you want to do with long method, you get the same answer. So under root 7 plus 2, under root 7 minus 2, under root 7 square minus 2 square, 7 minus 4. 7 minus 4 is 3. So 3 you can further simplify. 3 will come separately under root 6 under root 7 and 12 over 3. This give you 207 minus 4.